All right, here we go with page 11, talking about Venn diagrams today. The intersection of two sets A and B is where they overlap. A Venn diagram with A and B drawn on it will depict just this portion. That's the intersection of A and B. Every element of A is also an element of B. And B at the same time. The notation for intersection, does anybody remember? A blank B. Anybody remember the notation for the union? It looks like a little U with no tail. The union of A and B looks like that. Anybody want to guess what the intersection notation would look like? Upside down that. So this is where they overlap. The intersection is where they overlap, what they have in common. The union is keep it all. So the union, every element of A or every element of B, keep it all. It's easier sometimes to do these things when we have sample problems. So let's see the samples. Soda machine at work has 6 types of soda. Oh, that's one. 6. Abby likes cola, root beer, orange. Brent, orange, grape, strawberry. Debbie, lemon lime, and strawberry. Does anybody like grape soda? It's too sugary for me. I used to love it. Tasted like candy, but now I don't care for it. Do Abby and Brent have any sodas in common? Look at the Abby line, look at the Brent line. Do they share any common sodas? They do, right? And what soda do they both like? So, orange is the intersection of Abby and Brent. They share these. With the intersection, this upside down U, you only keep what they have in common. You only keep where this set overlaps with this set is the set that contains orange. And you're done. Let's draw a Venn diagram showing Abby and Brent's tooth decay bad habit. Does anybody not drink soda at all? Good for you. I try not to, but occasionally I have to have it. To fill in Venn diagrams, I like to fill the innermost part first. What do they share? What do they have in common? We'll put that in this overlappage football shaped item. And what should we put there? Orange. Then fill out the rest of Abby's likes, cola and root beer. Fill out the rest of Brent's likes, orange, grape, and strawberry. And then dangling out here in the universal set, remember when we call the universal set, it's the letter U. Don't get that confused with the symbol for union that doesn't have the tail. What kind of sodas do neither of these two kids like? Cola. We got Abby likes one. Say it again. Lemon lime. So we took care of all the sodas Abby liked these three. Brent liked these three. They overlap in orange, and neither of them likes lemon lime. So far, so good? Yeah.
So is the union of A and B everything inside the Venn diagram?
Everything inside A and B except for lemon lime. Yep. So the intersection, we're going to have to shade a bunch of these. Shading them on Pearson's fun. You just click the zone and it colors it in. The intersection is just this. It's where they overlap. So we would shade just this football shaped region. Now, let's look at the union of these. What if we went to get the soda from the machine and make sure that it would satisfy either Abby or Brent? So I put the money in the machine, I pull out a soda can, and I want to give it to Abby or Brent. Okay, it doesn't matter who. What's the only soda that could pop out of there and not make at least one of those kids happy? Lemon lime. So if I pop out any of the other sodas, that's the union of those. So we got to list them. Union means list every element of one, list every element of the other, and keep them all. So the union typically is going to be a lot larger. Okay. Do you have to list them more than once? No. So let's start listing them. Cola, root beer, orange. Don't have to list orange again. Grape and strawberry. Krogs. That's the union of those two sets. So if you were drawing a Venn diagram for the union of those two sets, I still list them just like we did before. The union shaded would be shade all of this circle and shade all of this circle. So we're shading everything in both of these circles and keeping it all. Union's nice. Intersection is only keep where they overlap. Does anybody have any questions? I do. What they want to put on this line, they wanted just to list them all out. Root beer, orange, grape. What's your favorite kind of soda then, you two? The non-soda drinkers don't. Do you like those machines where you get to choose? Does the movie theater have that now? Yeah. So that's nice. You just give them a cup and they walk away. And then you have to go clean up their messes. Did I forget one? Strawberry. Johnny, he likes strawberry Sprite. That would be a great combination. And you can make it at the theater if you go and watch a movie. Say what? Lime Sprite. Yeah, I'll bet it is. They used to have that. It's called the Green River. You can ask your parents or maybe even grandparents about getting a Green River. Next, draw a Venn diagram. Oh, did we already do that? No, Abby and Debbie. So this time we're going to use Abby's preferences and Debbie's preferences. The first place that I like to start is where they overlap. So flip back a page and see where Abby and Debbie overlap. What soda do they have in common? Does Abby have anything in common with Debbie? No, none. So we fill in that innermost circle first, and nothing goes in there. Tomorrow we're going to talk about counting the values that are inside those areas. So 0 different colas live in that zone. And then Abby's colas are cola, root beer, and orange. Debbie's root beer, she likes the fruity ones, lemon, lime, and strawberry. They have nothing in common. Is there an additional soda that neither one likes and it would float in the universal set? Great. And we took care of all of them. So, do they have any sodas in common? No. Since they don't have any sodas in common, the other way to draw this Venn diagram would be the circles don't overlap. Or they don't even have to touch. Do you know what it's called when two sets don't overlap? They are disjoint sets, where their overlappage has 0 items. We'll talk more about that tomorrow. Let's try to answer a couple of questions from problem number 1 and 2 here. Find the union between A and C. Union is the easier of the two, I think. Here are all the letters we have to choose from. Here's A and here's C. So basically, you start writing them down, and union, keep everything you write. Writing down everything from A. Writing everything down from C, and then we keep it all. There's no need to list the duplicates more than once. So we've already included B, we've already included C, and we write down everything in set C. Union means write it all down, keep it all down, and you don't have to write the repeats more than once. Theoretically, you're supposed to put it in alphabetical order. I do not think Pearson cares. Okay. How about B intersects C? That is, only write down where B overlaps C. What do they have in common? Do they have anything in common? Is it just F? And done. That's where they overlap. Notice that these overlappages and unions are each sets when you're done with them. Where does A overlap B? Nowhere at all. They have nothing in common. So we're either going to call that the empty set, or we're going to call it the empty set. And we can conclude that A and B are disjoint. What's B union with the empty set? Union means write it down, everything that's in B, we write it all down. Then we write down everything in the empty set. The empty set is empty, so there's nothing else to write down, and we keep it all. Intersection is a little bit tougher. We have to see where A overlaps with the empty set. What do they have in common? So, what does A have in common with the empty set? Nothing. It's the empty set. Is that okay? And we can work these things out from left to right, just like our order of operations. So working this thing from left to right. Let's figure out what is in the union of A and B. The union means write everything down in A, write everything down in B, and keep it all, but only write down the letters once. A, B, C, D, E, F, G, H. Now we union that with C. So now we write down everything in C. I've already written a B, so I don't have to do it again. C's already there, F is already there, and I is the only thing I need to add. And keep them all. Is there a faster way for me to represent this? We could call it,
Universal set?
you could call it U, or the universal set. It contains everything. Does that sound good? You guys want to do some more? Will you tell me how to stop this? Go in here, click that, and click